So in today's video we will be talking about the functions. So functions are small piece of code that helps you save time and space. Suppose if you want to repeat some operation multiple times, you need not copy paste that code multiple times. Instead you can write that code in a function and you can simply call that function or call running that function multiple times. So let's see how to do this. So we have already seen the main function in our previous programs. So the function declaration starts with the fn keyword followed by the name of the function. In our case this is the main function, and we can see here the brackets, normal brackets. Here we can pass some parameters, but here we do not have any parameters, and this opening brace and closing brace contains the code that is inside this function. So the code inside these braces belongs to the main function. So the program execution starts from the main function of any project. We can also declare any other functions as well. So similar way, fn and followed by the name of the function. So let's say count up to, and here we can see this is the function we have declared. The name of the function is count up to, and here we can take the arguments or parameters. So the advantage of parameters is you can customize the function. We can say x colon i32. So that means x is taking of the type i32. If you do not put this x, it will raise an error because the rest compiler does not know what type of data type we are passing. So we need to specify the i32 value. You can also pass multiple parameters as well by separating with comma. So y i32 comma z i32. So we are passing three values, those are of i32, so signed 32-bit integers. So you can pass multiple values as well. Now we can calculate the sum of numbers up to this value. So for I in 1 dot dot x plus 1, so 1 to this number, and we need to let's declare a counter value, and for every loop we are going to add this I value. So we are adding 0 plus 1 plus 2 plus 3 and so on up to x. Now finally we can print this value. Now let's go and run this one, and here we can see there is no output because the function has been declared and it is sitting right there. It is not doing anything. We need to call that function and we need to run that. So calling the function is same as running. So the function won't get executed until you call that one. So how to call this one? So you can say count up to, so the name of the function brackets and the parameters we want to pass. So we want to pass a i32 value, so let's say 10. Now let's run this and we should see the output 55. Here is one problem because the value is being printed inside this function and this function cannot access that value. Sometimes in almost many cases we want to use that value calculated inside that function. So that's why there are return values. So we can return this value using the arrow mark. So you declare an arrow like this, hyphen and greater than. So this will tell the return type. So in other programming languages we need to define the return type here, but in here we can say like this one, i32. So that means we are returning of the type i32. Now here we can see the red line because we did not return any value yet. So let's go and return this one. So return counter. Now we can see we are returning the value to this function and that value will be placed here. We can store that value inside this result. Now let's run this. You will not see output because okay, you will see output from this function. So let's comment out this one and let's run this again. Now we don't see any output because we are just storing the value, we are not printing to the console. Now let's go and print this value. Now you should see 55. So this is how the return type works. So let's delete this one. And another method of returning is, so this is the normal and the only way you can return in other programming languages, by using the return keyword and the value and the semicolon. But there is another way to return the value in the Rust, that is simply putting the value in the line without any semicolon. So Rust will identify if there is no semicolon, and it will identify this value as a return value. So just simply put the value you want to return without any semicolon. Now let's go and run this, and we should see 55 value. So these are two ways of returning the value. If you are I am comfortable with the return variable name semicolon, because I'm coming from other languages. The standard return type declaration is this one, so we'll be sticking to this syntax. So okay, by default the functions are private. You can you need to declare as this keyword pub to make them public. So in the modules we'll be discussing the public, but here we are in the same module, so that's why the pub is not that much necessary. Now you can pass the array as well. So let's declare another function, let's say adder, and this will take an argument array. So you can pass integers, arrays, vectors and strings as well. Anything you can pass. Okay, so now there will be one problem. So if I declare like this, you can see the size is unknown at the compile time. So Rust is very strict. We can say a slice of array. So this should be fine. Now what we can do is, let me comment out this one. Now let's declare an array. So we have 5 elements in an array, and we can pass a reference to this array. Okay, so let's say adder of ampersand error. Now let's go and run this, and the program there will be no errors because we are passing a reference to an array. Now we can print that array as well. So you can pass vectors as well. So this will be very interesting, passing vectors. So let's generate a vector 0.50 dot collect. So I'm collecting as a vector of i32 type. So I will get a vector v1, let's say, that is of i32. So this vector stores the i32 values. Now this is the interesting part. So since these vectors and strings are stored on heap, and if you remember from the ownership video, now if you change this one to vector of i32 type and pass this vector, it should be fine, everything will be fine. So let's run this one. Let's also print this, and we can see all the values in hexadecimal. Okay, so let's remove this. Okay, so up to now this is fine. Now I want to access this vector, and I will get an error. v1, because this value has been moved into this function, and this function did not return anything, or it's just printed those values and did nothing. So let's run this and we'll get an error. Value borrowed here after move. So where the value has been moved into the adder function. So we cannot access this one because this is invalid. The values inside these function are called local variables, and these local variables gets dropped after the function execution. So how to resolve this one? You need to put ampersand, that is a reference to the vector. So change this to the reference to the vector, and now we should be fine. So here you can see the error was gone. So let's run this. We get the we are printing 2 times, yes, once inside the function and once outside the function. So this is how you resolve using the reference, and you can also return the type. So let's say public function random generation. So let's say return type as ampersand str. So this will gives us some error because the ampersand str is a reference, and we cannot pass reference as a return type because after the function completed, those references will be invalid. So let's say let name is equals to text 69. So this is a reference, and I am going to return this one. Now you will get an error. So we need to declare the lifetime. So we'll be discussing in the future videos. So for now we can return this as a string. Return name dot to string. So okay, this should be fine. Now I can directly print this value, generate a random generation, right? Yes. Now we should see the string text 69. Okay. We can also add do something called generic. So that will take generic type. I will make separate video on generics because we will be writing 2 functions, fill structure from array and fill structure from memory. For those functions, these generics are very helpful. So generics are like generic data type. So instead of i32, what if the user wants to pass i8 or i16 or i64? So that's why we can use generics to calculate or to get multiple types of similar parameters. So this can be any type of the vector. So that's how generics will be. So we'll be seeing the generics in the future videos. So that's all about the functions in Rust.